Good afternoon, everyone. My name is Lee Atkinson. I'm a solutions architect for AWS, based in the UK team, based in London. I primarily work with media and entertainment customers, but we're going to talk about the edge services specifically here. So if anybody was here last year, you may have recognized the title of this presentation. This is an updated version of this presentation. I actually delivered this presentation last year. I think it was the day before Lambda Edge was announced, therefore I couldn't talk about Lambda Edge. So with the updated version today, I can talk about Lambda Edge. So, the agenda. We're going to talk about what we mean, or what I mean, I would say, regarding the AWS Edge. We're going to talk about the application edge, and then patterns for a DevOps edge. Before I go on to the next slide, I just want to set the scene around what I mean by DevOps. I'm not going to talk about everything about DevOps, the DevOps culture. I'm just going to take the important essences of DevOps, the idea of working together as a team. You've got developers and operations, building a solution, integrating a solution, automating it, testing it, monitoring. That's the principles I'm going to talk about here using AWS Edge Services. So what do I mean by the AWS Edge? So the first thing we can talk about is the infrastructure, the edge infrastructure. So to start off, we have 44 availability zones, or AZs. I'm British, but I still call them AZs. And these are grouped into 16 AWS regions. We've got 17 AZs and 6 regions already announced. So the AWS regions themselves, that's where the majority of AWS services running, executing, so things like EC2, S3, etc. But in addition to these regions, there's also the AWS Edge Network. These Edge Network, we have 107 points of presence. We launched another 6 last week. And of those 107 points of presence, we have 96 edge locations and 11 regional edge caches. Now, the edge locations are small. You could think of those as smaller instances of infrastructure for AWS. These are close to the user. They're connected to users' ISPs, network connections, to be as close to the users as possible. The regional edge caches are actually located in the AWS regions, and these provide extra features which I'll talk about later. We've also got the AWS Edge services. So these services run in the AWS Edge network. Some of them will also run in the regions. So to go through them in a list, there's Amazon CloudFront, our content delivery network, Amazon Route 53, our DNS service, AWS WAF, our web application firewall, AWS Shield, our DDoS protection service, and AWS Lambda Edge. Now, CloudFront runs both in the regional edge caches and the edge locations. Route 53, the actual DNS servers are running in the edge locations. AWS WAF and AWS Shield both run in the regions and in the edge locations. And Lambda Edge is running in the edge network, providing Lambda, so the standard Lambda that we use for serverless compute. Lambda Edge is running in response to events of CloudFront, so requests and responses coming into the CloudFront network. So, the next thing is to talk about the application edge. So often we think about your application as being the origin and the client. What I mean by the origin is, if you look at the specification for HTTP, it talks about the origin rather than a web server. So the origin is where the content is originating from. So it could be a static web server, it could be S3, but it's more likely to be a web server that's generating content. So the origin runs on EC2, ELB, S3. It could run somewhere else on the internet, could run in your own data centers, for instance. And then you've got the client. The client is the interaction with the origin. So it could be an HTML, it could be a website, a web browser, it could be a mobile application or a desktop application. And often people will classically think that you have this. Effectively, it's a client-server application. Your client's making requests to the server. It just happens to be a web server. The web server responds, and the client is rendering and working with that content. The key point I want to get today is to think about, actually, there's one more component of that application. And it's the edge in between the origin and the client. So the edge is DNS, CloudFront, the content delivery network, and also perimeter protection using AWS WAF and AWS Shield. And additionally, we also have Lambda Edge, so we can also do compute at the edge. The key thing here is often people think of DNS and CloudFront, or DNS and CDNs, I should say, as something as a bit of an afterthought. So you may build your application and you build your client and you put them together and you're working, and maybe you need a performance boost. So you think about, well, actually, I should add caching. So I will use a CDN and I'll configure the CDN to do caching. I need a domain name, so I'll buy a domain name. I will configure that domain name to point to my web servers. So often these DNS and CDN are often an afterthought, and often they're also not part of the application itself in the design of the application and the deployment of the application. It's often done by a separate team. AWS WAF and AWS Shield, the security protection, may also be done by the security team rather than the application team. So my key point here is to actually treat all three components as part of your application and work together. Even if you're separate teams, you're working together to deploy this application. So just a few points on CloudFront. So CloudFront helps improve the user experience. So I'm going to run through a request from a client for a website that's fronted with CloudFront. So you've got at the top, you've got the origin, so the web server that's going to originate the content. The bottom left, you've got the clients. In this case, they are mobile devices. And then we've got CloudFront in the middle. I'm just showing the edge locations. I'm not showing the regional edge caches for the moment. I will talk about that later. I'm just trying to keep the diagram as simple as possible. So the first thing to do is the client's going to make a request to the website to get some content. Now, the first thing it's got to do is got to establish, but even before it makes an HTTP request, it's got to establish a TCP connection. One thing I should have said just before. Key point, all of the main public AWS regions are all on the Amazon backbone, and many of the AWS edge locations are all on the Amazon backbone. Now, the benefits of it all being on the Amazon backbone is the performance improvements that we can offer, the tuning that we can provide, the more that you can stay on the Amazon backbone delivering content to your users, the better performance you'll get. So the client makes a request. It's first got to establish a TCP connection. Now, to establish a TCP connection, you've got to make a three-way handshake. So the packets have to transfer between the client and the edge location, backwards and forwards, to establish that TCP connection before it can even make an HTTP request. So the shorter the distance you making this TCP connection, the quicker that connection can be made. So the benefit of using CloudFront is that the edge locations are located as close to the users as possible, that initial TCP connection can be set up as quickly as possible. So once you set up the TCP connection, the client can make an HTTP request to CloudFront to receive the piece of content. Now, in this case, it's not in the CloudFront cache, so CloudFront edge location is going to make a request back to the origin server. Now, it's going to do the same thing of establishing a TCP connection. Now, this is over a longer distance, typically, so it will take longer to establish, but the one benefit is that that TCP connection is a persistent connection. So once the connection is set up, we'll keep that TCP connection persistent, open for future requests. So we've now established the TCP connection. We can make the HTTP requests, get it back into CloudFront, and then we can deliver it to the client. And optionally, we can store that object in the cache of CloudFront for a future request. So let's say a second client makes a request for the same object. It's going to have to establish this TCP connection again. The advantage is it's over a small distance, so it can be configured and set up quickly. And then it can make the request. Now, in this case, it's already in the CloudFront cache, so the object can be delivered back to the client without even the edge location have to make a second request back to the origin. Now, if it did have to make a second request, the advantage is that that persistent connection between the edge location and the origin is already established. So even if the request has to go back to the origin, it'll be quicker than going directly to the origin, because over the part of the distance, the TCP connection is already established. So CloudFront isn't just for static content. Even if your website is completely dynamic, there's still a benefit in user experience and user performance by using CloudFront, because you've got persistent connections and that the majority of the traffic is going over the Amazon backbone until that last section from the edge location to the client. As I mentioned, there's also regional edge caches. And a regional edge cache sits between the edge location and the origin. The regional edge caches, they're based in the region, so they have a great deal of cache bandwidth, or cache width, I should say. So that means you get a better cache performance, better cache hit ratio, because this cache is wider, and it's also shared across the edge locations within that area. So that means even if the edge location hasn't got a cached object, it can go back to the regional edge cache before the regional edge cache would have to go back all the way to the origin. So the regional edge caches provide even better cache performance. And it also takes more load off the origin, because not every single request from a regional edge cache, or say from an edge location, would go back to the region, all the way back to the origin. So you've got a mid-tier cache. Another point to be made with CloudFront is it helps to reduce the costs. So the first thing is data transfer from an AWS region. So if your origin is based in an AWS region, whether it's EC2 or S3 or ELB, the data transfer from that region to CloudFront is free. You don't pay for the data transfer. You only pay for the data transfer out of CloudFront itself. And this is charged at a lower data rate than the out of an AWS region. So by using CloudFront, you get a cost saving typically. Whether you're using it for caching or not, you'll be using CloudFront and the lower data charges to deliver content to your end users. Now, if you do cache content, that means that you'll make fewer requests back to the origin. And because you're going to have fewer persistent connections going back to the, or fewer connections going back to the origin, because you're only going to have the regional edge caches making those connections back to your origin, it means there's less load on the origin. So there's less CPU, less memory usage, which often means that you can actually scale your origin to a smaller size and therefore save money as well. So the next section is to talk about patterns for a DevOps edge. You can think of this as just some tips that you may want to consider. So I've got 5 in total. The key thing is to try and cache as much content as possible at the edge, to think about forwarding as little information back to the origin, and I'll explain that and we'll work through these and explain that later. To try and validate content, so validate whether you've got the most recent version in your cache as efficiently as possible, to automate the edge, and also to monitor it. So let's just talk about cache as much as possible. So I'm just going to explain how HTTP cache control works. This is not specific to CloudFront at all. This is just the HTTP specification. So in this example, I've got the origin and a client. The client's going to make a request to the origin. So the first thing it does, it issues a request. So you can see here that I'm going to get a bar chart.jpg. I've specified here HTTP 1.1. A key point to just to note is that CloudFront also supports HTTP 2. It provides better performance, but I'm not going to focus on that. I'm just focused on HTTP request itself. So it's issued that request. Now the origin is going to return the object, and with that object it's going to specify a few extra headers. So last modified is fairly obvious. It's a date and time, basically when the last time that object was modified. But the key one I want to talk about is cache control. So cache control is a header that is sent from the origin to the client to indicate and direct and provide information about how it can cache that object and when it would need to validate that cached object in the future. So there's a number of different directives within the cache control header. I've set one here, it's called max age. 1800 means 1800 seconds, so that's 30 minutes. And what max age means is effectively the origin is saying to the client, here is the object, you can cache it, and you can keep on using that cached object, but in 30 minutes time, if you use it again, come back to me and validate that you've still got the most recent version. I may have a newer version that you may want to use instead. What it's not necessarily saying is you have to cache it for 1800 seconds. It's totally up to the client how long it will cache that object for. It may choose not to. It may be a small device that doesn't have the capacity to cache. So don't assume just because the origin is saying to the client 1800 seconds that the client will obey and cache it for 1800 seconds. It's also not saying that cache it for 1800 seconds, but after 1800 seconds, delete it. All it's saying is, if you do cache it, after 1800 seconds, come back to me and validate that you've got the current version. There's a few other directives that you can also add. Another one that's very similar to max age is called smax age. The S stands for shared. So what this is saying is the max age is for the client. Smax age means shared cache. So effectively, if there's any caches in between the origin and the client that are shared, so this could be a content delivery network, it could be an office cache, it could be an ISP cache, anything like that that's shared that's going to have multiple clients using it, it's going to set a different max age. So what it says here is setting 900, so it's a shorter time. Effectively what it's saying is, to the shared caches, you need to come back and validate you've got the current version earlier than the client needs to. Another one is private. So this is effectively saying, max age, 1800 seconds, but private. I don't want this cached in a shared cache, only to be cached in a private cache, which is typically the browser's cache, because obviously it's only used by one user. There's another one called no cache. Now, people often think no cache, oh, that means not to cache. It doesn't actually mean not to cache. It means you can cache it, but you must validate with me before you use it again. So it will get cached by the client, or it can be cached by the client, but if the client's going to use it in the future, even though it's in the cache, it must come back to the origin to validate, to make sure it's got the current version. No store is where it means do not store the cached object. Don't store it in your cache. You need to come back every time and make a new request for the object. So I'm going to stick with the max age, 1800 seconds. I'm also going to add an E tag, which is short for entity tag. So this is, you can think of this as the versioning of the object. It's just a text string. Often many applications will use some sort of hashing function on the object itself as an E tag. But the actual value itself is what we call opaque. It means you shouldn't infer what it means. You shouldn't infer that it's an MD5 hash. Often it is, but you shouldn't infer that. All it means is if you've got two E tags or two objects, if their E tags are different, it means that the objects are different. If they are the same, the objects are the same. It's basically a versioning of that object. So the origin returns that object to the client, and then it displays it, and optionally it can cache that object. So now, if it's in the object, if it's in the cache, the client can continue to use it. So if it goes to another web page with the same, referencing the same object, it can just display that out of the cache. It doesn't need to go back to the origin again. But after those 30 minutes, although it may still be in the cache, it needs to now validate with the origin to make sure that it's got the current version, the most up-to-date version. So in this case, it will do a conditional get. So the get itself is exactly the same, but we've got this extra header. It's called an if none match. What this is saying is, I want barchart.jpg, but only send it to me if the E tag is different to the E tag I've already got in my cache. So let's assume that the object hasn't changed. It's still the same version. It would be the same E tag. So the origin can just respond saying, not modified. Basically, you've got the current version. You can continue to use that's already cached. But let's assume that the object has been updated. So the client makes a request. It specifies the E tag and the if-none match. But the E tag of the current object is now different. So the origin returns that object. And as you can see, the E tag is different. It's specifying cache control again. So all this is just standard HTTP specification. The origin is defining how long it could be cached, how long it should be before it needs to be validated. But CloudFront understands cache control. So when you've got CloudFront in between the origin and the client, if it sees this cache control directives coming from the origin, it will then use that to determine how long and whether that content can be stored in its cache. But as well as the cache control header defining how long the content should stay in the CloudFront cache before it needs to be revalidated, CloudFront also supports the configuration as well, through configuration, the TTL. So the TTL that you set in CloudFront can be set at the cache behavior level. A cache behavior in CloudFront is defined as a group of configuration which is applied based on matching the path of the request. So you have these TTLs that can be configured in CloudFront. You've got these cache control headers. How does CloudFront determine which one to use? So I've got a flow diagram here just to walk through the decision that CloudFront makes on a response from an origin on how long it should store it in the cache before it needs to revalidate for the future request. So CloudFront prefers the SMAX age. If the SMAX age is there, it will then use that as the TTL. If SMAX age in the cache control header is not there, it will then fall back to using the max age. There's another header which is called expires. It's a header that was specified in an earlier version of HTTP. It's still valid, still used. The difference between expires and, say, cache control is that expires is a simpler header. It's got less functionality. And what you do is, rather than specifying a maximum age, you specify a point in time, a date and time. Typically, it's in the future. But at that point, the cached object needs to be revalidated. So if you haven't got a cache control with a SMAX age or a max age in your response, CloudFront will then use the expires header. Though I'd recommend that you try and use cache control wherever you can in your application. It gives you a lot more functionality. So after looking at all those headers within the response from the origin, CloudFront has now got a TTL that's been defined by the origin. But if it doesn't find any of those, it will use the configured default TTL. So this is a specified number of seconds that it will store in the cache, store the object in its cache before it goes back to the origin to revalidate that it's got the current version. So now we've got the origin has defined a TTL, but we can also put restrictions on the maximum and the minimum of that TTL. So max TTL is another configuration within CloudFront. Now if the TTL that we found from the origin is actually greater than max TTL, we'll actually use the max TTL value. And similarly for the minimum TTL, min TTL, if the TTL defined by the origin is actually lower than the min TTL, we'll override that and use the min TTL. So now, once we took the constraints, the minimum and the maximum TTL, we've now defined the TTL that CloudFront is going to use in its cache. One thing I want to point out is that CloudFront won't actually change the cache control header as it's passing through. So even if you set a maximum TTL of, say, 60 seconds, the origin defines 2 minutes, CloudFront won't change the cache control that it passes on to the client. The client will still receive that 2 minutes. It's just that CloudFront will only use the TTL of 60 seconds. Another thing to think about is how you can increase the cacheability of an object. The ideal thing is you can try and store your responses in CloudFront, or any HTTP cache for that matter, for as long as possible. You want to have the cache hit ratio as close to 100% as possible. It's hard to do, especially when you've got dynamic content, you've got personalized content, but the thing what you want to try and do is to strive to get the cache hit ratio as high as possible. Why do you want to do that? That improves the performance, it reduces the latency of delivering content to the users, and also it reduces the cost and reduces the load on your origin servers. But let's just take a random website, let's say, just any random website. And if you look at a website itself, there's lots of different components of a web page. You've got images and scripts and style sheets, etc. There's quite a lot of HTML there. Now, the thing is with HTTP, the cache control header is for the whole of that object that you return. So whether you return an HTML page or an image or a JavaScript file, you can only specify the cache control or the cacheability of that response for the whole of the response. But if we just focus in on the HTML content of this web page, I understand it's quite hard to work out, but let's just say looking at the HTML content of the website, most of that is pretty, you would say, static. So for instance, if I look for things like shop by department, that text is not going to change. Obviously, it would be different for a different language, but it will stay the same for a long time. But there are certain parts of that HTML page which are a bit more dynamic, a bit different. So customer since 2000. So I've been an Amazon customer since the year 2000. That's not going to change for me. I will always be a customer since the year 2000. However, other people will have different years. So this is the difference between dynamic content and static content, but also whether it's personalized content, because it's personalized to me, but it's static to me. Similarly to my name is fairly static. I'm not planning to change my name, so the name in the website is static. However, I might change my name at some time in the future. So it's static, it's unlikely to change, but there's a possibility that it could change in the future. And then there's components which do change often. Yeah. The basket will change. I would like to see the basket update as soon as I put something in the basket. And it's likely the recent orders will change as well. So within just this web page, content within that web page has slightly different caching characteristics. There'll be content that won't change for a long time. There'll be content that will never change. There's content that's specific to me and it would be different to you. But then there's also personalized content and dynamic content which change often, and I would like to see that change. If I put something in the basket, I would expect to see an update in that basket. Now, how do we do all this? It's quite difficult. All I could do is set the HTML page, probably set a cache control max age of 1 second. That's all I could do. I'd have to set it specifically so that this object is cached just for me, so it has my name in it. And if I put something in a basket, I would like to see an update immediately. But that means that then I've got to set that cache level for the whole of that object. And if I want to be as efficient as possible, I need to think of other options. Now, one thing I could use is to generate this object. So take things from the cache and generate a combined object. And the one option to do that is you could do that in the client. We've got a web browser, we've got JavaScript, we can run that, we can pull in content from an API to add and change that web page and update it so it's specifically for me. And you might notice there are some websites that will dynamically update and change. One example in the UK, if I look at the BBC News website, I can see changes in that website as things update, as it adds my username into that website. When I'm outside of the UK, I see advertising appearing. Inside the UK, I don't see advertising. All that content is being dynamically modified, the website. And that's really to improve, that improves the cacheability of that object, of that website. So moving on to the next one, we've got forward as little as possible. So what do I mean by forwarding? This is when CloudFront receives a request for a piece of content, and it's not in the cache, it's going to forward that request to the origin. Now, it doesn't forward the whole of the request. it will forward certain components, certain parts of that request to the origin, for the origin to return a response. So these components are things such as the HTTP method, the path, query string, headers, cookies. Now, whenever you forward something to the origin, there's a possibility that your origin could respond to that extra bit of information, that particular header value or that particular cookie value. It will vary the response that it sends back to you. If you're going to vary the response, you need to store that under a separate cache object. So what happens is at CloudFront, whatever you forward, CloudFront will add that particular component, the value of that component, to the cache key. So for instance, as an example, if you were to forward a cookie value, the session cookie value, that would make sense. For instance, let's say an account web page, my account web page is different to your account web page. So I would configure CloudFront to forward the session cookie so that I get a version, you get a version, they are cached separately, so only I can see my cached version, only you can see your cached version. But as you add these forwarded values, and they're being added to the cache key, that has a tendency to reduce your cache hit ratio. So you want to try and make sure that you don't send forward unnecessarily components in your requests. So let's just walk through this. So here's an example HTTP request. Now CloudFront will always forward the HTTP method and the path of the request. You can't change that. That's always sent, and they will always be a part of the cache key for CloudFront. You can also specify the query string. So by default, the query string is not forwarded, but you can enable the query string forwarding. And you can also specify the specific values that get added to the cache key. So in this example, I'll be forwarding the whole query string to the origin, but I only want widget to be added to the cache key. I can forward all headers, so I can just configure to forward all headers. But also, I could be specific about header. I could forward just the host header. That's often used. You may have a web servers that are actually hosting multiple websites, so you probably need to identify the actual host that's coming in. So CloudFront can forward the host header, so on your origin, you can identify the website that's being requested. You can also forward it accept language. Maybe I've got a multi-language website, so I need the information about the language of the user to determine what language I return as a response. I can also forward all cookies, but also I can actually be very specific in the cookies I want. So I mentioned earlier about a session cookie. Perhaps this particular web page, the session has no impact, so it doesn't vary the response. Let's say it could be like a help section on a website. So it's the same no matter who the user is, but perhaps I do vary the response based on, say, the currency that I've selected or the theme I've selected. So I can be specific in which cookies I'm going to forward to the origin, and therefore allow it to vary that response. So here's some tips for forwarding. As I mentioned before, only forward what can vary the response. There's no point forwarding all headers if there's headers that you're not going to vary the response on. Try and forward the headers or the cookies that you actually need at the origin. You want to try and maximize the cache hit ratio as much as possible. Ideally, you want to reduce the variability of forwarded values. What I mean by that is if you're forwarding a header and it could have potentially many different values, each one will be stored as a separate cache with a separate cache key. If you can constrain and reduce the variability of that value, you limit the number of potential cache keys you'll have. That will improve the cache hit ratio and improve the performance. Often some people might want to track the user or log information about the user on the request. So they might want to forward everything like the session key, the session cookie maybe. If they forward the session cookie, they know that that particular user went to that particular website or that particular part of the website. But if that particular part of the website is going to look the same no matter who the user is, you're going to be generating that response each time. It's going to be stored as a separate cache object. You're going to reduce your cache hit ratio even though the responses are identical every single time. If you do want to log and track the user, their journey through the website, Consider using CloudFront access logs, or perhaps including a beacon in your website. So this might be just a single 1-pixel image that you do forward that particular session cookie back to CloudFront and back to the origin. But it's just a small thing that's going back, and it's unobtrusive. It won't slow down the viewing of the website. Most of that can then still be cached. Another thing is, don't forward for authorization, so including authorization headers so that you can authorize on the origin whether the users should be able to access the content. Try and use things that are built into CloudFront, such as signed URLs and signed cookies, or things like geo-restrictions or AWS WAF to authorize and restrict access to your users, but still maintaining the cacheability of the object. And then finally, using the HTTP vary response header. Now, CloudFront doesn't use the vary header. Effectively, the vary header is part of the HTTP specification. It's allowing the origin to say to downstream caches and to the client itself, the web browser itself, I will vary the response in the future if this particular header is a different value. So it's a good thing to do for downstream caches. It doesn't have any impact on CloudFront, but it's just the best, good advice to use that. CloudFront determines the cache key, effectively, what will vary the response through the configuration of forwarding headers and cookies. So I'm going to do an example here. So forwarding the user agent string. So perhaps let's just say I've got an application and I need to know what the user agent is. Perhaps I need to know whether it's a mobile device or whether it's a desktop device, for instance, so that I can vary what I return, the HTML I return, maybe the style sheet, or something to do with the size of the display, or something specific about that client. So I make an HTTP request to CloudFront. I've now configured CloudFront to forward the user agent. So what it does, it will forward the request back to the origin, and it will also include the user agent string. And the user agent string value will then be added to the cache key. The issue is that the user agent string varies considerably between different browsers. There's lots of information in there. So there's lots of versions, lots of different rendering engine versions, and all that sort of thing, operating systems. Often you probably don't need all that information to make your decision on what kind of response you return back to the client. So CloudFront's got this feature of including headers that it can generate itself. So this is an example here that it's the header CloudFront is mobile viewer. If you forward that header, that instructs CloudFront to inspect the user agent itself, extract the information about whether it's likely to be a mobile viewer, mobile browser. And if it is, it will then send this header and add true to it. If it's not a mobile viewer, it will still have the header, but it would just be false. But by doing this, you've reduced the variability. All that variability in the user agent strings has been reduced to a Boolean value. So that means that actually you're only going to cache 2 versions of the response, whether it's a mobile viewer or whether it's not. So that improves your cache hit ratio because CloudFront itself has extracted the information that you need to know, whether it's a mobile viewer or not. There's also one for tablet viewer, desktop, and for smart TV as well. But let's say you actually need to know a bit more information than that. You don't just want to know whether it's a mobile or a desktop browser. Maybe you want to know the particular browser itself. It's Firefox, Chrome, Edge, whatever. Maybe you also need to know the version. What you can now use is Lambda Edge. So Lambda Edge can be invoked on a viewer request. It can inspect the user agent that's been sent by the client and extract the information you want. So in this case, I'm extracting the browser product's name and its version, and I'm only sending that and forwarding that to the origin. So by doing that, I'm only going to send the information that the origin needs to know. I'm going to reduce the variability of the user agent string, therefore increase the cache hit ratio and improve performance. So here's for the code bit. So this is a Lambda Edge function that's doing just that. So we can see that I'm using a Node.js NPM module called user agent. So this is just a standard Node.js module that I'm going to include into my Lambda Edge function. What it's used is that it can pass the information in a user agent string and extract different types of information held within. So I'm including that into my function. And then if you see the exports handler, this is the function that's going to be executed by Lambda Edge whenever a request comes in from the viewer, from the client. I'm going to get the user agent header. I'm going to check that the user agent header exists. I'm going to feed the value of that user agent header into the user agent module, the library that I'm using. And then I'm going to rewrite the user agent header and set the value so that it's the user agent family / user agent version number. Once I've set that, I then call back to Lambda Edge, and then Lambda Edge will then set that, and CloudFront will forward that user agent with that normalized, simplified user agent string. So I've now maximized the cache hit ratio as much as possible because I'm only sending the information that I need back to the origin. Here's another example. So WebP is an image format. It's more optimized than typically other image formats, but it's not supported in all browsers. So in this example, what I want to do is I want to use WebP and return WebP to the browsers, but only if they support the WebP format. Now I could use a user agent example previously. So I could send the user agent and the version, send it back to the origin. I could then use the origin to determine whether that user agent supports WebP. The issue with that is I'm going to have to support and define and determine which versions support WebP and which don't, and then I'm going to have to update it when the version numbers and new browsers come out, and maybe they will add that support later. HTTP has what's called the accept header. So the accept header in a request is indicating from the browser, from the user agent, I support files of this particular type. So in this example, what I'm doing is I'm looking for that header, accept. I'm looking to see if image/WebP, which is the content type for WebP, checking to see if that exists within the accept header. If it is there, then I know that the web browser is indicating to me that it supports WebP. So what I then do is I'm rewriting the URI, the request path. I'm actually taking the file extension off the end and replacing that with WebP. So what this is doing, it's going to change the request path that goes back to the origin. So the origin will get requests for WebP if I know that the browser is supported, or it's going to get a request, say, for a PNG file when I know that the web browser doesn't support WebP, it supports PNG. One of the things I need to do is to configure the ability that it will cache those as two separate versions as well. 'Cause what we don't want is to overwrite different image cached objects as well. So I've showed two examples where you can vary the response based on information that's returned by or given by the user agent. But I just also want to add the concept of using responsive web design. So it's great that we've got this power within Lambda Edge to do rewrites and extract information, but we've also got the functionality in most modern browsers to do responsive web design. So as an example, we can vary the look of a website based on things such as using CSS3 media selectors. So in this example, we're changing the design of the website, the layout of the website, client side, with no server required in this bit, purely through CSS style sheets. So the next thing to talk about is to validate efficiently. So important point to make is that HTTP itself doesn't support invalidation. The idea being that you can invalidate something that's already in an HTTP cache. Now, many CDNs support invalidation, so including CloudFront. And obviously, if you've got control and ownership of your origin service, you can invalidate local caches there. But what you can't do is you can't invalidate content downstream. You can't invalidate content that may be in an ISP cache or in a public cache. You can't invalidate content in a browser cache. So although you can invalidate content in CloudFront, it's not really the answer when you want to update, you want to change, you've got a new version of content. The better way is to use validation. Validation is built into HTTP spec. I mentioned it previously. It's what's called conditional HTTP requests. So I can say, perform this particular action, but only if. So for examples, if modified, give me the object, but only if it's modified since this particular date and time. Or the other one I mentioned was if none match. So that would be a case of give me the object, but only if the entity tag, the E tag, is different to the one I've got. If match is used for things like if you're doing a put, if you're putting an object, you may only want to overwrite an object if you know the object that's currently stored. So for instance, if I download an object, I make a change and I do a put, if I want to ensure that I'm actually overwriting the version that I previously had, I could use an if match conditional put. Now, if the object hasn't changed in a conditional get, the origin should return a 304 not modified. This indicates to the client, you've got the current version, continue to use that from your cache. Now, the origin itself could determine, how would it determine whether it's not modified? One option is, I will generate the response, I will talk to my database, I will render the response, and then I will generate the E tag. I might do a hash, and then I'll realize, well, actually, it's exactly the same E tag as you've already got in your cache. And that's fine, but then you've used a lot of CPU cycles and you've called your database just to find out that actually they've already got that same version. So options around this is sometimes to be able to determine maybe you've got the old version. So you could store, for instance, the E tag in the database. So you could check the E tag in the database or in a in-memory cache to determine whether the client has got the current version and therefore save CPU time by generating the response unnecessarily. Often, some people will often use a lower shared max age, S max age, and a higher max age. So what this means is content will stay in the cache of the object and before it's validated in the client longer, but you will actually refresh the content in the shared caches. Sometimes the reason is that it's not too bad if the user has received an object that they keep using that object for a longer term, but maybe a new user, you want the most up-to-date object. And then also consider using URL versioning if you want to cache bust. If you want to update an object and basically bypass the cache, this is often done things such as like JavaScripts. So JavaScripts are typically, they don't change that often, so it's good practice to cache that as long as possible. But when you do make that change, you often want to make that change fairly quickly. So one thing to do is to upload that JavaScript and give it a different name, so that and refer to that new version. So when a new request is made, you'll get that new version and it won't respond with the old version because that's in a completely different part of the cache with a different cache key. So the next thing to talk about is automating the edge. So these sort of key things for, obviously, like many AWS services, we've got the ability to control our edge services using APIs. It's probably more of a traditional thing that other CDNs are controlled typically through a console, through a web GUI, possibly having to engage with professional services. AWS Edge services themselves are controlled through an API. You can use the web console, you can use an API, you can use the AWS SDKs. There's no reason for you to engage with professional services or engage with a partner unless you want to. It allows you to make changes immediately. You can work it and you can develop it as you develop your application. And a key thing is also that these edge services are deployable through in CloudFormation. So you can create a CloudFormation template that defines your origin application as well as your edge services and deploy the changes using CloudFormation. One other thing is also that IAM is supported across these different edge services. So again, you've got that access control to make modifications and changes. So let's think about the edge as code. So I've got an example here. It's fairly simple. I'm using Route 53 to host the DNS name, the domain name for that website. I've got CloudFront as the content delivery, serving the content. I'm using AWS WAF to protect my application. And I'm also using AWS Certificate Manager to provide a SSL TLS certificate to my website. And in this example, I've just got a single origin running in EU West 1, and it's a load balancer with EC2 servers. But let's say I've got some static content I want to store. I could store them on my web servers, but the other option is I could store it on S3. So now the static content is being served out of S3, means I don't need to have as many EC2 servers because I'm only serving dynamic content from those. Perhaps I've got web servers located in my data center. I can also have those as origins behind CloudFront. And then perhaps maybe I decide I'm going global, therefore I create a new origin server as close to my users as I can. I host that in US West 1. And then I could use Amazon Route 53 latency-based routing to route requests to the nearest origin for that particular CloudFront edge location. Now, all of these have been performed using CloudFormation. So whenever I want to make a change, I can update my CloudFormation template and deploy the update to make that change, all through code rather than making changes through the console. I can also use AWS Lambda to make changes. So for instance, I could update my AWS WAF configuration, responding to known attacks. And I can also use Lambda Edge on my CloudFront distribution. Now, all of this can be deployed using AWS CodePipeline. So I can have a CloudFormation template. I can use code commit to store that and version it. I can then deploy that to a development CloudFront distribution, do the testing, and then deploy it to a production CloudFront distribution. And all of this can be done using AWS CodePipeline. Now, when I did this session last year, I did do a demo. There's a time constraint for this year with extra content. Therefore, if you want to see a demo, if you search for taking DevOps to the edge, reInvent 2016 on YouTube, there's a link there, but that will show you a recording of last year's session where I do a demo using CodePipeline to deploy changes to CloudFront. Another thing I want to mention is AWS WAF security automations. So this is a collection of code and templates to do automated configuration of AWS WAF, such as checking for IP reputation lists. So if there's bad reputations on particular IP addresses, AWS WAF can be automated to block those IP addresses. There's many different types of rules, such as bad bot detection. So even if you specify in your robots.txt file to robots shouldn't go to a particular URL, if they go there, you know that they're behaving badly, and therefore you can block them. And in addition, we launched this week the ability for partner-managed AWS WAF rules as well. So the last section, monitor the edge. So Route 53, CloudFront, AWS WAF, and Lambda Edge, they all support CloudTrail. So CloudTrail will log activity against the APIs of those particular AWS services. So it will allow you to track what's happening against your services or your resources within those services. These services are also supported in CloudWatch metrics and alarms, so you can set metrics around CloudFront and DNS, etc., and set alerts as well. CloudFront also supports reporting, so you can see error rates, geographical locations of clients making the requests. And you've also got access logs of CloudFront. So these are standard W3C formatted log files. And these are delivered to an S3 bucket that you configure when you're creating your CloudFront distribution. And you can use, for instance, AWS Glue to take the log files, perhaps enrich those log files, add extra information. Maybe it's content, stuff that you've logged in your application. You could add those to your CloudFront access logs. And then from there, you can then start to store the content in S3 or in Redshift, and then use Amazon QuickSight to analyze that content and visualize that content. You can also use Amazon Athena against the log files in S3 to query that data using SQL. Or you can use your favorite W3 log parser. So that's all the patterns for the DevOps Edge. And the final key takeaways I have for you key point is to consider the AWS Edge as part of your application. It's not something that you add on at the end of your project. It's something that you should consider right at the beginning of your project. And also to think that your AWS Edge configuration will change and adapt over time. As your application adapts and evolves, so your Edge configuration should do. Key point is to optimize and use caching efficiently. So your aim is to maximize your cache hit ratio so that as much content can be served out of the CloudFront cache as possible. So try and be as efficiently as possible. So reduce the variability, reduce how much you forward back to your origin. Automate your configuration of AWS Edge. So this can be done using CloudFormation to automate it, but also think about using things like AWS Lambda to automate your configuration, to vary your AWS WAF rules in response to known threats. And then finally, to monitor your AWS Edge using CloudTrail, CloudWatch, and also the service logs that the individual services provide. That's the end of the session. Thank you very much.